All right, so today we're going to talk about climate change, and one thing that I've tried to emphasize throughout the semester is that all of these different kinds of Earth systems are very interconnected, and the climate, which talks about conditions of the atmosphere, doesn't only change the atmosphere, but what's going on in the atmosphere has big implications for all the different other kinds of Earth systems that exist around us, and certainly can affect us as humans as we live on the environment on the planet Earth. So we've talked about climate change a couple different times so far, but I kind of want to recap some of the information that we know. So we know that we can go back through the ice record data and we can look at gas bubbles that have been trapped in the ice to make inferences about the condition of the atmosphere in the past. And by doing that, we can see that, one, the level of carbon dioxide in the atmosphere has been variable over time. It's not something that's constant. But we can also see that recently we've experienced this real spike in the carbon dioxide levels that have placed it way off of the charts in comparison to kind of the recent history of the Earth. And so it's much, much higher than has been any time in the last million years. And if we consider the fact that modern humans have only been around for 200,000 years, this level is much, much higher than in any time in human history. The other thing that we know is that carbon dioxide and temperature are very well correlated. So as temperature goes up, carbon dioxide goes up. As carbon dioxide goes up, temperature goes up. And also by looking at this ice core data, we can look at the oxygen isotopes, remember, in the gas bubbles, and we can see when there's more heavy and light oxygen, and by that we can infer when the temperatures were high in the past and when they were low in the past, and we can see that these two variables track very well with each other. So as we're experiencing this spike in carbon dioxide levels in the atmosphere today, we should expect that we will experience a spike in temperature as well. So that's kind of the physical or fundamental background that we're dealing with. Then we know that we are experiencing a spike in temperature around the world today, and we expect that this is going to continue. So already the average surface temperature around the Earth is warmer, about 2 degrees Fahrenheit warmer than it was back in the 1880s when we kind of first started collecting comprehensive data around the world about temperatures. And I have a short video clip here that I'm going to show you that illustrates this change in global surface temperature. So areas in this video that are shown in yellow and orange and red mean that the temperatures are higher than the average temperature throughout the last 100+ years, and the areas that are blue show areas that are experiencing temperatures that are lower than the average temperature over this time period. So it's going to take us from the late 1800s up to the present, and we'll see how the globe has changed. All right, so this NASA simulation shows very clearly that the Earth's temperature today is several degrees warmer on average than it has been in the past. So the question for us now is that how will the temperature continue to change? We know we've already started to experience influences from this warmer temperature around the Earth, and we expect that with greater temperature change, we'll experience greater impacts. And so there's a lot of scientists that are working very hard to try to understand what the future may hold for us. And in particular, there's a group of scientists that collectively are called the IPCC, which stands for the Intergovernmental Panel on Climate Change, and this is a group of scientists from many countries all around the globe that have pledged to work together for the last couple of decades to try to make these reports about the most up-to-date science that relates to climate so that policymakers from all countries all over the world can use this information to help them make decisions. So again, this isn't something that's just done by the U.S. government. There are many U.S. scientists that are involved in the IPCC, but this is kind of a global effort. And all the figures and data that I have in this presentation are, for the most part, from the most recent IPCC report. We are expecting another IPCC report to come out this year, but these are the figures from the last report that was published about 5 years ago. So what this report shows us is that in the future, we expect that the CO2 concentration in the atmosphere will increase, and some estimates say that it will likely double compared to 1850 levels by the end of the century. That was from a study by NASA. And we know that since these things are so closely tied, temperature should continue to increase at the same in a comparable way. But there's a lot of different variables that might influence how much carbon dioxide increases. And so some of these have to do with variables in nature that we don't have control over or a perfect understanding of, like influence of cloud cover and other things like that. But a lot of it has to do with policy decisions that we make as humans in different societies around the globe. So are we going to make big investments in clean, renewable energy? Or are we going to continue to be very dependent on fossil fuels? How are we going to regulate these things or have other means of encouraging humans to change away from these fuels that create this problem to different kinds of energy sources? And so a lot of that is unknown, and as a result we can't make one prediction about what the future may hold, but instead what this study does, and what a lot of studies do, is they make a range of predictions that kind of show us low and high-end potential places that we might be in the next 100 years. So this particular graph here shows one line that tells us what has already happened in gray, and then in the future the kind of different lines diverge. So there's one line in blue showing that if we make very, very aggressive change to move away from fossil fuel use, as is shown by this RCP 2.6, which stands for a representative concentration pathway with low concentration of carbon dioxide, then in that case we should still expect an increase in temperature by the end of the century of 1 degree Celsius compared to today. So that's about 2 degrees Fahrenheit. On the other hand, if we stay on this trajectory RCP 8.5, which is kind of a business as usual projection, we don't make effort, we don't make commitment to change our behavior, then we would expect to see an increase of 4 degrees Celsius or 8 degrees Fahrenheit by the end of the century. So that's a pretty significant change, and probably will land somewhere in the middle of those two predicted values. So you might wonder, how does an 8 degree Fahrenheit change in temperature fit into a historical context? Have we been there before? What did it look like at that time? And so there's also been a lot of research into understanding the climate of the past by doing things like looking at ice core data, looking at data in corals and ocean sediments and other things like that. But what we know is that there's been many times in the Earth's history when the Earth was warmer than today. There's also been times when it was colder than today as well. But over the last 800,000 years, there were two periods of time, one about 140,000 years ago and one about 400,000 years ago, where we did have average global temperatures that were slightly higher than today. And those slightly higher temperatures were not much higher they were less than 1 degree Celsius higher than today. So less than our lowest possible prediction for where we might be at the end of the century. On the other hand, if we look back even farther in time, if we go back 4, 5, or 6 million years ago, we can see times when the Earth was pretty consistently warmer, and in those cases, it was somewhere between 1 to 2 degrees Celsius warmer than today. So somewhere in the 3 to 4 degrees Fahrenheit increase compared to today's temperature. So something that's very reasonable for us to see by the end of the century. Then what's so scary about this is that we also know that during these periods of time when the Earth was warmer by less than 1 degree Celsius or less than 2 degrees Celsius, we had huge shifts in global sea level. So we know that as oceans warm up, first of all, the water just expands, so it takes up a little bit more space and therefore increases along coastlines. But we also know that these warmer temperatures melt a lot of sea ice that's floating on top of the ocean and melt glaciers that then run off into the ocean. And so as a result, the sea level gets a lot higher. Something we've already started to see around the world, but it's something we know has been occurring in the past in times of warmer climate temperatures. So during those periods of time, 140,000 years ago and 400,000 years ago, when we have these slightly warmer temperatures, we can go around the Earth and look along coastlines and look at sediment records and look at erosional patterns, and we can see that at that time, the sea level was 13 to 20 vertical feet higher than today. So that's not feet up along the beach, that's vertical feet from today's level. And then going back even farther to times when the global temperature was approaching 2 degrees Celsius warmer, we had sea level that was as much as 50 to 80 vertical feet higher than today. So those are big changes that are pretty humbling to think about, especially if we remember that we are looking at possible increases in global temperature by the end of this century that you guys are living in that approach as much as 4 degrees Celsius increase in temperature. So I would like to point out that an increase in temperature for just 80 or 90 years would probably not be a long enough period to melt enough water to attain these high levels of sea level increase. But if these temperatures are maintained for longer periods of time, then we might start to see such extreme changes to sea level. But we should certainly be prepared to experience notable sea level rise during our lifetime. We know that we've already increased the sea level over 20 centimeters compared to 100 years ago, and we expect that rate of change to increase steeply in the next several decades. Okay, so we have a little bit of understanding of what has occurred in the past, how temperatures may change in the future, and so we also have acknowledged that the temperature of the planet and other climate variables have changed throughout time, and they've been more and less extreme than today. So many people might argue that, you know, the Earth is accustomed to these changes, and so we don't need to worry about them because the Earth has always been changing. And unfortunately, that's kind of a naive assertion because, one, they have not changed this much in the time that humans have existed on the planet. And so we have built our infrastructures and our societies around an understanding of the climate functioning in a certain way. And if the climate changes significantly, then we could be in some real trouble. And not only could we be in big trouble, but other organisms and other systems that we depend on could be shifting in significant ways as well. So a few of the major problems that are often brought up associated with sea level rise, I want to talk more specifically about here. And this isn't an exhaustive list, but this is just some examples that I thought we would bring up. So the first one we've already mentioned is sea level rise. Warmer temperatures are already rising, creating rises to sea level. Here's a picture at the bottom of the slide here of the Maldives. This is a kind of tropical island nation in the Indian Ocean, and it's a low-lying island nation. And so just small amounts of vertical sea level rise are covering huge extents of this island nation and displacing lots of people already. Biodiversity, changes to biodiversity with a changing climate are another set of concerns. And then also the increase of these kind of extreme weather events that are often kind of natural disaster type of events from a human perspective also appear to be on the rise with the shift in climate. So we'll go through and talk about each of these in a little bit more detail. Okay, so again, back to sea level rise. We kind of talked about what the sea level rise looked like in the past in warmer climates, but we'd also like to understand what we might be looking at in our lifetimes. And so just like the other graph of temperature, the IPCC worked to make a range of predictions that we might see based on different representative concentration pathways or different amounts of CO2 that may be in our atmosphere depending on our different kinds of societal and policy decisions. And so by the end of the century, they expect to see somewhere on the lower end, maybe around another 30 centimeters of sea level rise, up to over a meter of sea level rise, so more than 3 feet of sea level rise around the planet. And already, since this particular study came out 5 years ago, many scientists feel like this is a pretty conservative estimate that we may be seeing even faster rates. So that's something that we are already experiencing and certainly will be continuing to look out for. I have a video clip about melting glaciers and sea ice that are contributing to these changes to sea level rise, but I'm going to post that separately. So it's a short clip, about 10 minutes, and I do want everybody to watch that, but I'll post this clip from a feature-length film called Chasing Ice. And again, it's just a clip of this movie. I'll post it next to this PowerPoint on Canvas. Okay, so why should we be so concerned about sea level rise? If we lose a little bit of the beach, is it that bad? Well, unfortunately, we've already mentioned that some areas on the planet are very low-lying nations that are being completely engulfed by small amounts of sea level rise. And unfortunately, a lot of our global population lives very close to these low-lying coastal environments. So over 700 million people, about 10% of the global population, live within only 30 vertical feet of sea level. 2/3 of the world's largest cities are within this zone, and the United Nations predicts that by the middle of the century, so another 30 years from now, we will have as many as 30 million climate refugees that are being forced to move as a result of these types of changes. So here's a study that was not published in that IPCC report, but was done by our government, the National Oceanic and Atmospheric Association, or NOAA. And this is a map showing parts of the southeast and the Gulf states that are kind of the most consistently low-lying part of our country, and they're showing areas of land that will be engulfed with different levels of sea encroachment. And so you can see certain areas like New Orleans and many parts of coastal Florida and the Carolinas, Virginia, etc., are really quite vulnerable to changes, and these are areas that support big population centers. There was one interesting study that came out a few years ago about downtown Miami in particular. So Miami is right on the ocean. It's a very flat, low-lying area, and the study tried to illustrate the amount of the city that would be inundated with a 1 meter increase in sea level, so about 3 feet sea level increase. And remember, this is the kind of thing that's possible for us to see by the end of this century, so within your lifetime. And one of the main problems that's experienced by a lot of these areas like Miami is that They are built on a certain kind of geologic material called limestone that's very porous. If you can imagine, limestone is often made from kind of old corals that are kind of cemented together. And if you've ever seen little corals, they have all these little holes in them. And so even if Miami works to build a big seawall around the edge of the city, as places like New Orleans have done, the porous nature of the kind of bedrock on which the city is built is allowing water to come up from the ground and inundate the city from below, not just from the side. And so places like Miami are particularly vulnerable to these types of changes. Here's some photographs of some major flooding events that they've already experienced. These are usually associated with high tide events. So, you know, the combination of high tides with sea level rise is already resulting in some pretty extreme problems for that city. Okay, so sea level rise is not the only concern. Another major concern that scientists have is about how changes to climate might affect biodiversity around the world. So we've discussed extensively the fact that different kinds of organisms are adapted to live in specific climates and specific conditions, and they won't do very well if they try to change the environment in which they live. And so as we shift the climate, and especially as we shift the climate very rapidly, many of these organisms are finding themselves ill-equipped to be able to survive and reproduce in the environments where they've lived in the past. So sometimes they have the ability to move into new areas, but sometimes they don't, or sometimes they can't move fast enough or adapt fast enough to kind of keep up with these shifts in conditions. So there's many other things around the planet that are contributing to a loss of biodiversity that we do know for sure is occurring around the planet. Climate change is not the only thing, but we do know that many species are being additionally stressed by this, and we're certainly losing species as a result of this change in these environmental conditions. So to give you a little history about shifts in biodiversity, we know that throughout geologic history there have been periods of time that are called mass extinction events or extinction level events, where we have a pretty rapid reduction in the biodiversity around our planet, and we define these mass extinction or extinction level events as times when over 50% of the species have died out. And we can interpret this by looking at the fossil record and looking at when fossils exist, and then when they disappear, they kind of die out from the fossil record. And we know that each of these major extinction events is correlated in time, so lines up with a very rapid change to global climate. So sometimes these changes are towards warmer climates, or sometimes they're towards colder climates, but as we shift the environment quickly, organisms we know in the past have struggled to keep up and continue to survive. So you do not need to know the dates and the specific details of each of these mass extinctions. I'm just showing this to you to give you some context here. But here are dates, 440 million years ago up to 65 million years ago when we had some of these extinction level events. And you can see that there's different things that initiated these, but they all set off a period of either warming or cooling, usually with shifts in atmospheric conditions, maybe related to geologic activity like volcanoes, or biologic activity like plants colonizing the land and sucking CO2 out of the atmosphere. But in all these cases, a rapid shift in climatic conditions led to a huge loss of species. So there is a concern that we may be experiencing another sixth mass extinction today. So there's different ways that people describe this extinction that we are currently experiencing. Sometimes the sixth extinction, sometimes the Holocene extinction, which is the name for the geologic period that just ended, and then also sometimes called the Anthropocene. So anthro means man, so this kind of period of time that's defined by the influence of man or humans on the planet. And we know that we're losing species very fast, It is difficult for us to understand exactly how many species we're losing because we don't even know how many species are out there to start out with. Most people estimate, or kind of a median estimate for the number of species that might exist today is somewhere between 8 and 10 million species. And we think that we're probably experiencing extinctions on the ballpark of about 30,000 species per year. And again, both of these measurements have some uncertainty built into them. But if these facts are correct, then within the next 150 years, we will end up losing 50% of the species on the planet. So that's a really huge shift. And remember, these kinds of extinctions have only occurred about 5 times before, over the history of the planet. So this is a pretty remarkable thing to be a part of, and not a pretty remarkable thing in a positive way. You certainly, I imagine, all heard about different kinds of endangered or threatened species around the planet. There's many species that we, famously know have already disappeared, but here's a couple species: a local butterfly and the polar bear that are currently kind of in danger of becoming extinct. Okay, so a third potential concern associated with climate change is the fact that these warmer temperatures, greater evaporation rates, in some cases greater low pressure zones and wind speeds are initiating this kind of rash of extreme storm events around the planet. So we know that climate is a lot more than just changes to temperature, and we know that precipitation is shifting around the planet as a result of these changes. We're less confident about how the shifts to precipitation may play out at different parts of the planet compared to our real clarity about how shifts in temperature are occurring. But generally, people expect that we will see less frequent but more intense precipitation events. So we may have fewer days of rain in California, but when they occur, they might be more rain falling within a specific day. And of course, this could lead to bigger problems with flooding. We've already started to see this. So that's kind of the general pattern that we've been seeing around the world. And that makes sense if we think about the functioning of the atmosphere. We know warmer temperatures can evaporate more water, so they can hold more water in the atmosphere. We also know that warmer water has a higher water holding capacity. But then when temperatures shift and the water starts to come out of the atmosphere, if there's more stored there, then there's the ability for more water to come out and be dropped on the land in a specific event. Precipitation isn't the only thing that's going to change. There's a lot of other things that may be shifting as well. So you've maybe seen news media from around the world talking about extreme heat waves, talking about extreme droughts, extreme wildfires. We've seen a lot of these in the western United States in the last couple years. For instance, this past year, we saw the Mendocino complex in California, a wildfire that burned 460,000 acres. That's a really enormous area. We've also seen a rash of really major hurricanes and cyclonic storms, typhoons around the planet that we talked about earlier. And it doesn't just seem like these are happening more often, they really are happening more often. So this graph down here is a couple years out of date, but it shows already the change that we've seen over the past couple decades of these natural disasters in the United States. And this is actually data that's collected by the insurance industry. So kind of interesting that there's this kind of economic feedback from these changes to climate. So the insurance industry is being hurt by these changes because they're having to pay more out to people that have insurance. But you can see there's different kinds of events that can play out: climatological events, hydrologic events, meteorologic events. Those are shown in blue, dark green, and light green. And you can see that all those are on the rise. Whereas the geophysical events, things like earthquakes and volcanoes that are shown in red, do not appear to be on the rise. So those don't have such a clear feedback with climate. So anyway, we've seen a lot of the news about these natural disasters over the next couple years, or over the past couple years, and unfortunately we do expect that this kind of thing is going to continue to plague us in the future. So this is moving a little bit away from science, or a little bit away from physical geography per se, but I thought this is kind of another interesting study that came out last year that shows the economic damage in percent of county GDP around the planet associated with climate change into the next century, or up to the end of this century. And so you can see a lot of the areas in especially the southern states seem to be experiencing some real potential negative consequences associated with shifts to global climate. And then on the other hand, there may be some places that have the ability to grow more crops, or have a little bit of a different, potentially even positive in the short term impact to their economies associated with this change. Okay, so unfortunately we're out of time to talk more about physical geography this semester. So at this time I just want to take a couple minutes to try to re-emphasize a couple takeaways from the class. And the first one is that I want to re-emphasize the fact that all these systems are interconnected. So the water affects the air affects the water affects the living organisms, the water affects the geology affects the air, and all these things are very connected and feedback on one another. So trying to understand one without any understanding of the other is not kind of a good way to go about being an effective natural scientist. The other thing that I want to point out is that I think often people have this perspective that environmental science is kind of a luxury, that we can only think about that once we've considered other factors. And I think that's a really wrong way about looking at the world. We are all very, very dependent on the way that the ecosystem and the environment around us function, and often people that are poor have an even bigger potential vulnerability to being impacted by their environment. And so it's really not a luxury at all to spend time thinking about how our environment works and how we can encourage our environment to work for us in successful ways, rather than destroying kind of built-in feedback cycles that exist. A third point is that science, this way of looking at the world and collecting information to give us an understanding of how things work before we move forward to make decisions about what to do, is very, very important, and hopefully we'll continue to value that and emphasize that in our policy making in our country and around the world. Sometimes science gets overlooked as less important than certain kinds of economic values or other kinds of social values, and I think that's very short-sighted. And then I guess I just want to leave you with a quote from Jane Goodall, one of my personal heroes, and she says, "What you do makes a difference, so you have to decide what kind of difference you want to make." And there's a lot of ways to make important differences in your community and in your world, but I hope as you guys all go out and use your education as adults in our communities, that you think about what kind of difference you want to make in this world. So good luck to you all, and thanks for taking physical geography this semester.